Hello everyone. Let's proceed to the discussion of the second half of metabolism, which is, of course, anabolism. So recall that we are already done discussing the breakdown or the catabolic pathways of the macronutrients. So in this video discussion, you will be learning the anabolic pathways involving the macronutrients. So unlike the catabolism no nga gitunga na ko siya into 3 videos, kaning discussion would be tanan ni siya no nga macronutrients. Okay, so it's because mas daghan manggod or mas taas manggod ang mga topics involving catabolism of macronutrients. So since very short lang pud ni, so that's why I was able to condense all the anabolic pathways involving all the macronutrients. So I think this is only 55 slides. So yeah. Okay. So anabolism happens, guys, if there is an abundance of food intake, or if there is an abundance of calories or energy, there is an abundance of ATP. So therefore the body must be able to store those excess fuel in the form of glycogen and fat. Okay, recall, guys, that we cannot store proteins as proteins the way we store carbohydrates as glycogen or fats as triglycerides. So we can only store those but not proteins. Okay, and then I've told you that mas daghan yung tag storage of fats compared to glycogen. Pero ang unahon natog ang unahon nga i-full or punon is the glycogen storage. So recall that we have only approximately 500 grams of glycogen storage in the body. So once mapuno na siya, so ang fats na sad. So unahon ang glycogen. Just like if we break down nutrients, unahon na tong glycogen ay ang fats. Okay? So the first anabolic pathway that we will discuss is glycogenesis. So the synthesis of glycogen, and this is an energy consuming pathway because I have already discussed this during the introduction to metabolism that anabolic pathways require an energy input. So the ATP is broken down to ADP and pi, so that the energy would be released and would be captured for anabolism. Okay, so para makabuild og larger molecules, kinahanglan i-break down sa ATP para makuha nato ang energy ikan dito. Okay, and glycogenesis is also reductive. Okay, and especially the fatty acid synthesis, you will really see there nga nung kinahanglan og NAD pH, because you know that NAD pH kinahanglan siya kanang like kinahanglan nato na siya in order to do anabolism. So later ako na siya i-discuss. So glycogen is synthesized via uridine diphosphate glucose, so UDP glucose. So you know that glycogen is composed of many units of glucose, and in order for those glucose units to be combined together to form glycogen, an individual glucose must be combined with an activated nucleotide, which is in this case UDP or uridine diphosphate. Okay, so para ma-activate si glucose for glycogen synthesis, kinahanglan mo attach si glucose with UDP. Okay, so that UDP glucose is just attached with another UDP glucose hangtod nga maka-form og taas nga chain of UDP glucoses. So makahimo na dayon tag glycogen. Okay, so This is done primarily in the liver and in the muscles. Okay, remember. So glycogen synthesis and degradation utilize separate pathways. So we have already discussed no glycogenolysis. Okay. So yeah, glycogenesis and glycogenolysis are different pathways. Okay, so this is the summary, no, or this is an illustration that summarizes glycogenesis. Okay, so pila lang ka enzyme, no, ang involved. So remember that, guys, that glucose 6-phosphate is the first intermediate in sa ganit ni in glycolysis, di ba? But yeah, if sobra-sobra ang glucose, okay, dili dapat na siya i-convert, dili dapat na i-break down into pyruvate kay ngano sayang. Okay, dili pud pwede nga sobra-sobrang ATP supply nato. So para sa sunod, para magamit nato ang excess, store dapat siya. So one way to do that is to convert glucose 6-phosphate to glucose 1-phosphate by the enzyme phosphoglucomutase, and then from here pwede na dayon ta maka-produce og glycogen later on. Okay, so once glucose 6-phosphate is converted to glucose 1-phosphate, then padulong na dayon sa glycogen synthesis. So the first intermediate of glycogen synthesis nga dili na dapat siya pwede mo balik, no. So once na convert na siya diha, padulong na dayon sa glycogen synthesis, that intermediate is G1P or glucose 1-phosphate, and the enzyme that catalyzes that is phosphoglucomutase from G6P or glucose 6-phosphate. Okay, yeah, okay, but actually the main enzyme here is glycogen synthase, because this enzyme is the one that we regulate. Okay, so ako na siya i-discuss, no, as a next topic niya to, which would be regulation of metabolism. So si glycogen synthase ang ginamanipulate para ma-regulate nato ang rate of glycogenesis. Okay, so yeah, si Louis Lilor, he was awarded a Nobel Prize in Chemistry for discovering glycogenesis. Okay, so UDP glucose is the activated form of glucose. So sa bali, we will regard this as the step 1. Okay, then the step 2 involves the conversion of glucose 1-phosphate to an activated glucose moiety by combining it with a nucleotide which is called UDP. Okay, and then ma-release dayon ang phosphate group, no. So that's why mahimo na lang siyang UDP glucose. So the enzyme that catalyzes that reaction is UDP glucose pyrophosphatase. Am I recording ba? Okay, sige. I always forget to have this laser pointer. Okay. Yeah, so si UDP glucose pyrophosphatase ang enzyme responsible for that. Yeah, okay. So what I've said, UDP glucose is the activated form of glucose. So yeah, although the reaction is reversible, the hydrolysis of the pyrophosphate pushes it to the right. Okay, so this requires an input of energy. Okay, so why do you think or asa lugar ni makuha ng UTP? This was derived from ATP. So the adenosine moiety in ATP is just changed to uridine, okay, or to a uracil derivative, but it nevertheless consumes energy. Okay, kinagamit man og ATP. Okay, so that's why the glucose becomes activated due to an input of ATP in the form of UTP. Okay, so a primer of at least 4 units are required via glycogenin. Okay, so next would be combining UDP glucose with each other, okay, to form um, glucosyl units. So when you say glucosyl units, this is just a polymer of UDP glucose combined together via 1,4 glycosidic bonds. So alpha glycosidic bond. So the enzyme involved in that is the main enzyme, which is called glycogen synthase. Okay? So yeah, glycogen synthase catalyzes alpha 1,4 linkages. So this is the alpha 1,4 glycosidic bond. Remember that the kind of bond that binds glucose units together is called glycosidic bond, right? So kung sa amino acids, peptide bonds, ang sa carbohydrates kay glycosidic bonds. So, kani siya nga type of bonding is called alpha 1,4 linkage. This is different from other polysaccharides no, like recall cellulose. So, cellulose is just parehas ra siya sa glycogen no, that is composed of glucose units but lahi lang ang linkage. Beta man tong sa cellulose, and that is also the reason why cellulose is not digestible by human enzymes, because human enzymes cannot recognize the beta linkages in cellulose. So alpha lang actually ang gina-recognize sa amylase, sa human amylase. So that's why starch and glycogen lang ang ma-digest sa human amylases. So yeah, this is a glucosyl unit. Duha pa ka buok no, as shown here. So si glycogen synthase ang gaad og UDP glucose one at a time. So taman nga moabot na naog taas kayo nga chain nga moabot na siya thousands. So si glycogen synthase is the one that does that work. Okay, so imagine no siya ang gahimoan na then it adds UDP glucose to the growing chain one at a time. Okay. But before that no, before si glycogen synthase maka-catalyze aning reaction, kinahanglan sa og primer. So a primer is like mao na siya ang pinakauna nga i-produce sa si glycogen synthase. So the enzyme responsible for that is glycogenin. So si glycogenin siya sa ang maghimo aning primer no. So magbuhat sa siya og upat ka buok. Okay? Then at kung at least nakaproduce na og glucosyl units that have 4 glucose residues, diha na dayon mag-take over si glycogen synthase to add more UDP glucose taman nga makaproduce ta glycogen. Okay? The last enzyme that is very important also, and this is responsible for the branching structure of glycogen. That is the unsa nga enzyme? Branching enzyme. Okay, simply called as branching enzyme or glycogen branching enzyme. So, linear man ni siya ang ginahimo sa glycogen synthase. But para makaproduce tag mga branches pareha sa ani, kinahanglan og glycogen branching enzyme. Okay? Kung dili ni siya mo branch out, guys, kung walay mga walay mga branches, normal glycogen would not be produced. And actually naay mga genetic disorders nga walay branching enzyme ang tao no, and then as a result kana siya nga person no would suffer many health consequences. One of it is development of plaques. It's because the purpose of why kinahanglan mag-branch out ang glycogen chains to make it more soluble. So kung straight lang siya, then dili kayo siya mahimong water soluble, then it would form plaques in the liver and worse in the heart, leading to many consequences or worse, death, early death. Okay? So, yeah, branching increases the solubility of glycogen. Okay, so that's why this enzyme is very important. Because the real structure of glycogen is really not linear, but it has branches. So, kaning mga branches, this is alpha 1,6 linkage. Okay? Yeah, that's the linear is alpha 1,4 linkage nga type of glycosidic bond. Kaning mga branches, alpha 1,6 na. Okay, so the enzyme breaks the alpha 1,4 link and forms an alpha 1,6 link. So, this is done by glycogen branching enzyme. So, at this point, nakabuhat na ka glycogen. Okay? So, that is glycogen synthesis. So, when blood glucose levels are high, insulin activates protein phosphatase 1, which stimulates glycogen synthesis. So this is accomplished through a complex, highly regulated signal transduction pathway. So glycogen metabolism in liver regulates blood glucose levels. Okay, so that's why guys, you know that insulin is anabolic, di ba? And glucagon is catabolic. So this is the real mechanism why insulin promotes anabolism, because it activates the enzyme glycogen synthase in order to upregulate or in order to increase the rate of glycogenesis. And this usually happens after eating. This usually happens postprandial. When you say postprandial, that is after meal. So, di ba mo taas man atong blood glucose levels after meal? So, that's the time that the pancreas would be stimulated to release insulin so that the glucose levels would be lowered. Kaya nga naman, asa man ipadulong itong mga glucose, nga nung mugamay man siya sa blood para for the cells to take up, and then pwede na dayon ta makaproduce og glycogen out of the glucose nga na-absorb, most especially no kung daghan og glucose. So dapat ma-activate si glycogenesis. Okay. So yeah, so diri na nato na ibaw nganong si insulin anabolic siya kay ga-promote siya og glycogenesis. So blood glucose levels rise after ingestion of carbohydrates, so postprandial, leading to glycogen synthesis. So phosphorylase is, remember, the enzyme that is largely responsible for glycogenolysis. And for in this case, glycogen synthesis or glycogenesis, glycogen synthase is the enzyme largely responsible. So when glucose added, glycogen synthase would be activated. So you can see here that the activity of glycogen synthase increases once glucose is added. So this happens after meals, di ba? After tanagkaon. So that si synthase ma-activate and then ma-activate ang glycogenesis. And as a consequence, due to the increase in insulin, si glucagon sad mo mubo. And kung mumubo si glucagon, phosphorylase activity would also be lowered. Okay? So, basta kung mutaas si insulin, ma-activate si glycogen synthase, then ma-deactivate si glycogen phosphorylase. Because glycogenesis and glycogenolysis are actually antagonistic. So, kung ma-promote ang isa, ma-deactivate ang isa. So, the same is true kung balihon nimo ang case. So, say for example, there is a need to break down glycogen. So, mutaas dapat si glucagon, then mubo si insulin. So, therefore, ma-activate dapat si glycogen phosphorylase, then ma-deactivate si glycogen synthase. Okay? So, inactivation of phosphorylase and an activation of glycogen synthase. So, this happens when insulin rises. But, when glucagon rises, balihon lang nimo. Okay? So that mag-stick ta sa atong nahibaw-an nga ang insulin anabolic, then ang glucagon catabolic. Okay? So that's the relationship between glycogenesis and glycogenolysis. Okay? Sige. So yeah, as what I've said, katong glucagon, starved state, so catabolic, so stimulates glycogenolysis. Then inhibits glycogen synthesis. In times of abundance, this is fed state, so glucagon decreases and insulin increases. So therefore, ang ma-stimulate is glycogen synthesis and ang ma-inhibit is glycogenolysis. Okay? Sige. So, that is anabolism of carbohydrates. What about anabolism of fats? Okay. So, mao ni siyang mahitabo guys no if kung mapuno na ang storage for glycogen, which is only approximately 500 grams, so the excess glucose, the excess amino acids beyond that threshold will now be diverted to the production of fats. Okay. So the major building block for the synthesis of triacylglycerols in tissues other than adipose tissue is glycerol 3-phosphate. So what about adipose tissue? So adipocytes lack glycerol kinase, therefore the 3C-D hap produced during glycolysis is the precursor for triacylglycerol synthesis in adipose tissue. So this means that adipocytes must have glucose to oxidize in order to store fatty acids in the form of triacylglycerols. Okay. So there are two anabolic pathways for this. First is fatty acid synthesis and lipogenesis. So fatty acid synthesis is just when you produce fatty acids, and then if you want to combine those fatty acids with glycerol, then that is lipogenesis already, because lipogenesis is triacylglycerol synthesis. So lahi siya sa fatty acid synthesis. Okay, but the precursor of lipogenesis is fatty acid synthesis, because of course, ang kinahanglan man sa lipogenesis is fatty acids and glycerol para makaproduce kag fat, di ba? But when you want to produce the fatty acids part, the fatty acid lang, then dapat fatty acid synthesis. So this occur primarily in the cytoplasm of liver, adipose, or fat cells, in the cytoplasm of neuronal cells or nervous cells or neurons, and then also in the cells composing the mammary gland. Okay. Kaya kinahanglan man na siya for milk production ang fat. So remember guys that the same hormones also apply to fat synthesis, no? Glucagon is still catabolic and insulin is still anabolic. So insulin is the one that stimulates this fatty acid synthesis and lipogenesis. And the breakdown of fats, which is called lipolysis, and the oxidation of fatty acids, which is called beta oxidation. So na-discuss na ito during the catabolism of fats. The hormones responsible for the stimulation of those catabolic pathways are glucagon and epinephrine. Okay? Yeah. So fatty acid synthesis and oxidation, okay, the counterpart of fatty acid synthesis is beta oxidation. And then fatty acid synthesis is just the reverse of beta oxidation. Okay? So mao ni ang comparison nila, no. Mao ni ang mga differences nila. So the pathway for fatty acid synthesis is in cytoplasm, and then recall that beta oxidation occurs in the mitochondria. Okay? So lipogenesis involves oxidation of NADPH, and beta oxidation involves the reduction of FADH and NADH. So remember guys, no, nga naatay ma-produce nga FADH2 and NADH, di ba, sa beta oxidation. So but in fatty acid synthesis guys, si NADPH ma-oxidize. Okay, so bali bali siya. Okay, later makita natin why NADPH is consumed in fatty acid synthesis. So, fatty acid synthesis uses a multi-enzyme complex called fatty acid synthase. Then, fatty acid degradation uses individual enzymes not necessarily physically associated. So, fatty acid synthesis intermediates are carried by ACP or acyl carrier protein, and while in beta oxidation, kaning fatty acid spiral, no, the same lang na with beta oxidation, CoA is the carrier for the intermediates. So ACP is just the activated form of fatty acids. Okay. So the essential chemistry of the two processes are basically reversals of each other. So both beta oxidation and fatty acid synthesis use activated 2 intermediate, which is called acetyl-CoA. So acetyl-CoA in fatty acid synthesis is temporarily bound to enzyme complex as malonyl-CoA. So the synthesis of malonyl-CoA is the first step of fatty acid synthesis. Okay, so therefore the production of malonyl-CoA is the first step of fatty acid synthesis. Okay, but first acetyl-CoA must be delivered from the mitochondrial matrix to the cytoplasm. That is being accomplished by the shuttle system called citrate malate pyruvate. Okay, this shuttle delivers the acetyl-CoA from mitochondrion to the cytosol. So, reverse, no? This is also the reason, okay, nga nung kinahanglan sa cytoplasm po ng fatty acid synthesis para dili ma-confuse ang cell. So, naay compartment, no, naay compartmentalization. So, ato na siya i-discuss po sa regulation. So that fatty acid synthesis would occur here, which is physically separate from beta oxidation, which only happens inside the mitochondria. Okay? So, most of the acetyl-CoA kay naaman sa sulod sa mitochondria. So, it must be delivered to the cytosol via this shuttle system. So, provides acetyl-CoA to cytosol for biosynthesis of fatty acids. So, this is also a cycle. Parehas po sa beta oxidation that the addition of acetyl-CoA is done one at a time. Or rather, beta oxidation, the breaking down of acetyl-CoA is done at a time. So, diba, if you want to completely break down a palmitic acid molecule into 8 acetyl-CoA, so that is done one at a time. So that one palmitic acid would undergo 7 rounds of beta oxidation. So same sa fatty acid synthesis na ay mga cycle. So in order to produce one palmitic acid, fatty acid this series of steps must occur 7 times. Okay, para makaproduce ka og one palmitic acid molecule. Okay? Sige. So, the activated acetyl-CoA, which is called acetyl-CoA, is combined with malonyl ACP to form acetoacetyl ACP. Okay, so in the process, one ACP is released. So this is the condensation step. Then acetoacetyl ACP is converted to beta hydroxybutyryl ACP. So this is a hydrogenation step. And this is the step where a NADPH molecule is oxidized to NADP. So unlike katong sa fatty acid sa beta oxidation nga ma-reduce si NAD to NADH, diri si NADPH ma-oxidize para makaproduce og NADP. So that ma-reduce si acetoacetyl ACP, forming now the beta hydroxybutyryl ACP. Okay? So, naay energy input. This is actually an energy input. This is endergonic. Okay? So, kaning NADPH manggod, this is very costly to produce. ato ni siya i-produce sa pentose phosphate pathway, which later atong i-discuss, no? So, beta hydroxyl butyryl ACP is then converted to crotonyl ACP, and that is a dehydration process kay a water molecule is removed man. Then, crotonyl ACP is finally converted to butyryl ACP, and another NADPH is expended. Another NADPH is oxidized to NADP, forming now the butyryl ACP. And this is a hydrogenation step, or this is a reduction step. So the sequence of cycles needed to produce C16 fatty acid or palmitic acid from acetyl ACP. Okay. Yeah. Okay. The cycle just repeats. Okay? Taman nga makaproduce ka og palmitic acid. Okay? Sige. So if we have palmitic acid, so it has to occur 7 times para makaproduce ka og C16. Okay? Kay kani sila, this is just 4 carbon raman ni. Kay malonyl ACP has just 2 carbon. So mag-combine siya with another 2 carbon, which is acetyl-CoA. Then makaproduce siya og butyryl. Okay, butyric acid, you know that it only has 4 carbon. So therefore, palmitic acid has, in order to produce one palmitic acid molecule, this cycle must occur 7 times. So therefore, pila ang magasto nato nga NADPH? Daghan. So 7 times 2, 14. 14 NADPH molecules are oxidized to NADP para makaproduce ta og isa ka fatty acid molecule. And I told you that energy input ni naggasto ta, nag-invest tag energy ani, which is to be expected because this is an anabolic process. Okay? Then asa gikan ning NADPH, ato na siya i-discuss sa pentose phosphate pathway. Okay. So the acyl group is now ready to condense with a new malonyl group to repeat the process. So when fatty acyl group becomes 16 carbons long, ethioesterase hydrolyzes it, forming free palmitate. Okay? Okay. So this is now your C16. So maproduce lugar og another 2, then na glycerol para makaproduce ta og 1 fat molecule. Okay? And that process is called lipogenesis. Palmitate is then released from the enzyme, okay? And then it can then undergo separate elongation and or unsaturation to produce, for example, if the body wants to produce an unsaturated fatty acid, so naay mga enzyme responsible for that, para makaproduce of double bonds. And if the body wants to extend the carbon chain from that C16, no, so naay mga elongase enzyme. Okay? Then naay mga unsaturated enzymes para makahimong double bond, so to yield other fatty acid molecules. Yeah, so beta oxidation and fatty acid synthesis are essentially just the reversals of each other. Okay. Next is cholesterol synthesis. So yeah, remember that cholesterol is also a very important topic in nutrition. So that's why we have to discuss how the body produces cholesterol. Okay, so cholesterol is used in every cell membrane. So cholesterol is the precursor of bile salts, vitamin D, okay, as discussed. Then adrenal hormones like glucocorticoids, mineralocorticoids, then sex hormones like estrogens, progesterone, for also for females, and androgens. So one androgen is testosterone. So these very important molecules kinahanglan og cholesterol. So si cholesterol ang ilahang precursor. Di ba si vitamin D, remember, that's 7-dehydrocholesterol ang iyahang kuan. Unsa ni ang iyahang precursor, di ba? Okay. Okay, so glucocorticoids, this is example ani cortisol, then mineralocorticoids, katong kuan, aldosterone. Okay, aldosterone is participates in the sodium and water retention, di ba, in renin, angiotensin, aldosterone hormonal system. Okay, so diri na gid nato makit-an ang mga integration sa katong mga na-discuss nato nga mga important biomolecules that have nutritional relevance. Okay. Yeah, okay. So pasalamat kita kay cholesterol kay makaproduce tag inani nga mga molecules that are very important. So the hormones that have cholesterol as the precursor is called steroid hormones. So when you say steroid hormones, ay ang precursor ana is cholesterol. Okay? Yeah, okay. Sige. So cholesterol has 27 carbons. Synthesis takes 15 acetyl-CoA molecules. So para makaproduce tag isa ka cholesterol, so this is a very big molecule, di ba? Kay 27 carbons good. Then para makaproduce ta og one cholesterol molecule, kinahanglan mag-condense or kinahanglan nato og 15 acetyl-CoA molecules. So si acetyl-CoA gyapon ang precursor sa cholesterol. So yeah, that's why acetyl-CoA is the central metabolite, because even in cholesterol synthesis, acetyl-CoA is needed. 27 separate enzymatic steps. Okay. Dili na nato i-discuss, guys, ang katong 27 nga enzymatic steps para makaproduce og isa ka cholesterol. But if you want to be a biochemist, then you really have to study these enzymatic steps. Okay. Cholesterol synthesis happens in the liver. So, the liver makes 1.5 to 2.0 grams per day of cholesterol. The average diet, okay, from our diet, usually makakuha tag 0.3 grams of cholesterol. Depende. If you are really into, cholesterol-rich foods, mas daghan pa yun ang imong makuha ani. Okay? Yeah. Okay. So, bile synthesis, happens in the liver. And para makaproduce og bile, kinahanglan og cholesterol. Okay, so that's why bile synthesis must also happen in the liver, because cholesterol synthesis happens in the liver. Okay. So, biosynthesis of cholesterol begins with 3 acetyl-CoA molecules forming mevalonic acid or mevalonate, which is a 6 carbon molecule. Okay? Taman nga makaproduce tag HMG-CoA. Okay? So, okay, HMG-CoA sa ang mahimo ay mevalonic acid or mevalonate. So the enzyme responsible for that is HMG-CoA reductase. And remember, guys, nga naapod diri NADH nga na-spend, no? Which is to be expected because cholesterol synthesis is an anabolic pathway. So therefore, it is an endergonic pathway. So it needs energy input. So, in the form of NADH. Okay? So, ma-oxidize si NADH forming NAD+. Okay? Para makaproduce ng mevalonate from HMG-CoA. And this is a very important enzyme sa cholesterol synthesis because this is the rate limiting um, enzyme in cholesterol synthesis. So remember, the rate limiting enzyme in glycogenesis is glycogen synthase. Then in glycogenolysis, that's glycogen phosphorylase. Then in fatty acid synthesis, that's fatty acid synthase. But in cholesterol synthesis, the rate limiting enzyme is HMG-CoA reductase. And we have to note this because this is the target of many drugs in order to lower the cholesterol levels. Ang tawag atong drugs are statins or statins. So these drugs lower cholesterol, so that's why they are called as cholesterol lowering drugs. So what is the mechanism of action? Statins inhibit HMG-CoA reductase so that mevalonate would not be produced. So therefore, kung walay ma-produce nga mevalonate, so cholesterol synthesis would be inhibited. Para kay makaproduce tag cholesterol, dapat kinahanglan makaproduce tag mevalonate. But if HMG-CoA reductase is inhibited by statin drugs, so therefore, cholesterol synthesis would be limited. So therefore, unsay effect, ma-lower ang cholesterol level sa body. Okay. So ang target ani nga mga drugs is the HMG-CoA reductase. So the next type you will encounter statin drugs. So those are cholesterol lowering drugs. This is usually administered for those patients who have cardiovascular diseases. Then ang problem is hypercholesterolemia. Okay? Yeah. So if you really want to study cholesterol synthesis, so this is the whole pathway of cholesterol synthesis. Daghan kayog enzymes involved. So para makaproduce ta ultimately og cholesterol, this is the first committed step. Produced catalyzed by the enzyme HMG-CoA reductase. Okay? Nindot ra pang mga pangalan, no? Isopentyl 5-pyrophosphate, dimethylallyl pyrophosphate, geranyl. Gananit kay ko ani nga enzyme. Geranyl PP or geranyl pyrophosphate. Then farnesyl pyrophosphate. Diba? Their names are very fancy. Okay, relationship between lipid and carbohydrate metabolism. So acetyl-CoA is the link between lipid and carbohydrate metabolic pathways. So glucose, glycerol, and fatty acids all degrade into acetyl-CoA. So that's why acetyl-CoA is the central metabolite. And amino acids also. Diba? Amino acids are converted to acetyl-CoA, especially katong mga ketogenic, no? Amino acids, okay? They can be produced to acetyl-CoA. And glucose can also be converted to acetyl-CoA via pyruvate, and glycerol can also be converted to acetyl-CoA via DHAP. Okay? Via glycolysis. And fatty acids can be converted directly to acetyl-CoA via beta oxidation. So that's why acetyl-CoA is the central metabolite, because all the catabolism of fats, carbohydrates, and proteins can lead to the formation of acetyl-CoA. Then also the catabolism of the anabolism of fatty acids, production of ketone bodies, and production of cholesterol all use acetyl-CoA. Remember, para makaproduce sa ketone bodies, kinahanglan gyapon og acetyl-CoA. And as discussed earlier, para makaproduce ng fatty acids, kinahanglan og acetyl-CoA. So that's why grabe gyud ni siya ka central. Okay, naa siya sa center sa metabolism. Kay apil sa anabolism, kinahanglan og acetyl-CoA as the precursor. Except na lang no sa glycogenesis. Okay? Kay dili man ta magkinahanglan og acetyl-CoA. Okay. Okay, so yeah, remember this. Ako na ni siya na-discuss. So you just have to read this. Okay, so if the body is overly rich in acetyl-CoA, uh, so this is assumed to be in the fed state. So kung well-fed ang tao, then na abundance of food. So na sobra-sobrang acetyl-CoA, na sobra-sobrang glucose. So they must be they must be stored. So that's why that's why ma-release si insulin para ma-activate ang mga anabolic pathways. Okay, so I will leave this for your own review ha. So at this point, actually daghan na gyud ta na discuss, di ba? Digestion, kani nga mga kuan, mga pathways, di ba? Yeah, so at this point maayo na kaayo mo sa metabolism. Okay? So at this point kabalo na gyud, or you will really be confident na, especially when you enter the med school. Kaya yan, alam mo sufficient background. So maupod ni ang kanindot sa ND because nag-focus ta sa metabolism, because metabolism is really nutrition, because the substrates that are involved in metabolism are nutrients. So that's why naagyo ni siya nga discussion. Okay, so let's now proceed to the last metabolic pathway that we will discuss, which is pentose phosphate pathway, or HMS. So HMS stands for hexose monophosphate shunt. So that is just the same with PPP, or pentose phosphate pathway. Okay, so remember that glucose 6-phosphate has many uses. Pwede siya glycolysis. Then glucose 6-phosphate wala lang nakabutang diri, no. Pwede siya mahimong glucose 1-phosphate to glycogen. So the reverse of glycogenolysis is just glycogenesis. So glucose 6-phosphate is converted to glucose 1-phosphate para makaproduce glycogen. But the other pathway that glucose 6-phosphate can take is the pentose phosphate pathway. So the pentose phosphate pathway is a shunt. So unsay pasabot sa shunt? Bali diversion. So diversion of glucose. Pero later on mag-diverge ra siya, or mag-combine ra siya with the common pathway. So the pathway begins with the glycolytic intermediate G6P, which is the product of step 1 of glycolysis. So it reconnects with glycolysis because two of the end products of PPP are glyceraldehyde 3-phosphate and fructose 6-phosphate, which are also intermediates of the glycolytic pathway. So it is for this reason that the pentose phosphate pathway is often referred to as a shunt, or hexose monophosphate shunt. So pentose phosphate pathway can be called as PPP in short. Okay, so this is just an illustration of the glucose flux, no? So when glucose are very abundant, just in this case, a shunt can be performed in the form of PPP. So kung very puno ang tubig, for example diri sa waterfall, so naay diversion nga nahitabo. So this happens when there is a large glucose influx in the body. So this happens in well-fed state, or so that's why this is an anabolic pathway, because this happens when there is an abundance of energy, or kung well-fed ta. Kung kanilang, then glycolysis lang ang mag-occur. But if mas daghan ang flux sa glucose, then a shunt must be performed via the PPP. So yeah. So remember guys that the first intermediate for PPP is G6P, which is the product of the step 1 of glycolysis. So kani kung sobra-sobra ang glucose, then kinahanglan ni siya i-divert to PPP. And then actually guys, nganong shunt siya kay later on makaproduce ra tag G3P and also fructose 6 phosphate. So later I will show you nganong ang PPP makaproduce ra og glycolytic intermediate. So meaning dili ra masayang, although it's a diversion, but di siya masayang, and this is a very efficient way to use the excess glucose para makaproduce ta og NADPH. Okay? So mao ni siya ang purpose ni PPP para makaproduce og NADPH. Remember that NADPH is used for fatty acid synthesis as previously discussed, di ba? So without NADPH, fatty acid synthesis would not occur. Okay? So therefore, NADPH is required for biosynthetic pathways or for anabolic pathways as the reducing power. Okay? So as it gives reducing potential. So the pathway yields reducing potential in the form of NADPH to be used in anabolic reactions requiring electrons. Okay, as previously shown and discussed in fatty acid synthesis. Then, PPP also provides glycolytic intermediate. So, bisag nagkuha ta og G6P, ibalik ra gyapon na later on sa end sa PPP. Ibalik ra na gyapon sa glycolysis. Pero, the advantage would be, sa diversion nga nahitabo, na ina-produce nga NADPH. So, therefore, the excess glucose is maximized para dili masayang. So, aside from converting glucose to glucose 1-phosphate and then to glycogen, pwede sad siya mag-undergo PPP. And the other purpose is to provide ribose 5-phosphate for the production of nucleotides. Remember guys that the sugar backbone of nucleotides is ribose, diba? And then the other one is deoxyribose, and that comes from ribose. So actually gikan na siya sa ribose 5-phosphate that is produced from PPP. Okay, so later makita ninyo na. So yeah, pathways requiring NADPH. So fatty acid biosynthesis, okay, cholesterol biosynthesis as previously shown, neurotransmitter biosynthesis, and nucleotide biosynthesis. So all of these require NADPH as their source of reducing power. And of course, for antioxidant system. Remember guys, di ba sa antioxidant system, kinsa man to mag-regenerate sa tanan nga mga antioxidants, di ba? So after glutathione, ma-oxidize si glutathione must be reduced back to the reduced form. So ang kinahanglan is NADPH, di ba? So yeah, so NADPH reduces all those radicals. Okay, so therefore this is a very powerful antioxidant. And also in cytochrome P450 monooxygenases, so these enzymes are involved in the detoxification of drugs in the liver. Okay, so tissues with active PPP. So PPP happens in these tissues. Okay? Kaya nga naman, since ang product sa PPP is NADPH, and then you know that NADPH is very much needed in cholesterol synthesis. So remember that steroid hormones are produced in the adrenal glands as well as in the gonads, in testes and ovary. So that's why kinahanglan nga na ay PPP dito para makaproduce og cholesterol, which is, you know, the precursor of steroid hormones nga na as sex hormones, and then mineralocorticoids and glucocorticoids, which are steroid hormones. Then liver for fatty acid synthesis and cholesterol synthesis. Then mammary glands, fatty acid synthesis for milk production, and red blood cells, maintenance of reduced glutathione. So, of course, red blood cells must be protected against free radicals. So, kinahanglan nga na NADPH dito. So, that's why na PPP nga gakahitabo sa red blood cells. So NADPH is phosphorylated form of NADH. So you just add another phosphate group sa NADH, may muna siyang NADPH. Okay? Remember that NADH is used to drive the oxidative phosphorylation in the ETC. Then NADPH, ang iyang function is to provide reducing power for anabolic reactions. For these anabolic reactions. Okay. So the PPP is actually divided into two phases. The oxidative phase, which is the phase 1, and then the non-oxidative phase, which is the phase 2. So in phase 1, this is where NADPH is produced. While in the phase 2, this is where the sugars are produced. So this is where ribose 5-phosphate is produced, and this is also where the glycolytic intermediates, the fructose 6-phosphate and G3P are produced. So phase 2 can be called as the non-oxidative phase of interconversion of sugars. So NADPH is formed from two separate reactions. So the enzyme responsible for the first step in the PPP is glucose 6-phosphate dehydrogenase. And this is also the one that is defective in those patients with glucose 6-phosphate dehydrogenase deficiency. Have you heard about G6PD? So the enzyme, the defect of that is G6PD leading to G6PD deficiency. So later I will provide a case study regarding G6PD deficiency. Then that converts G6P to 6-phosphogluconolactone. So 1 NADP is reduced to NADPH. And then in the third step, another NADPH is produced by the enzyme 6-phosphogluconate dehydrogenase, producing ribulose. So this is the start of the phase 2. So ang phase 1 diri ang ma-produce ang NADPH, but sa phase 2 diri ta maka-produce og many sugars that are used for synthesis of nucleotides and to be fed into the glycolysis in the form of F6P and glyceraldehyde 3-phosphate. Okay? So, the enzyme responsible for producing ribose phosphate from ribulose 5-phosphate is phosphopentose isomerase. And then the enzyme responsible for producing cellulose 5-phosphate from ribulose 5-phosphate is an epimerase enzyme. So to form pseudoheptulose 7-phosphate, so this is a 7-carbon sugar and a 3-carbon sugar, kinahanglan og transketolase. So transketolase just combines cellulose 5-phosphate with ribose 5-phosphate to form 10-carbon molecule. And then transketolase then cleaves that 10-carbon molecule into two sugars. One has 7 carbons and another one has 3 carbons. Okay, so gi-combine then gitunga lang into a 7-carbon molecule and into a 3-carbon molecule. This can then further be condensed by transaldolase, forming erythrose 4-phosphate and fructose 6-phosphate. So this is a 4-carbon molecule and this is a 6-carbon molecule. And fructose 6-phosphate enters the third step of the glycolysis para makaproduce og fructose 1,6-bisphosphate. So musulod na niya at this point, musulod na siya glycolysis. And at this point sad, si G3P magsulod sa step 5. Sa step 6. Okay, sa phase 2 sa glycolysis. And kani sa step 3. So, that's why PPP is a shunt kay mao ni actually ang main nga functioning PPP para lang makaproduce tag NADPH and then ma-divert ang excess glucose, then walay masayang nga glucose kay moderate ra man ni glycolysis, or kung sobra-sobra pag yun, then G3P is converted back to glucose via gluconeogenesis. Okay? Yeah, so this is the first phase of pentose phosphate pathway, which is the oxidative stage, because the intermediates are oxidized in order to reduce NADP para makaproduce tag NADPH. Okay? Then makaproduce tag ribulose 5-phosphate, then the phase 2 would occur, which is the non-oxidative reactions. Okay, so diri ta makaproduce og kato nga mga sugars, no. Okay, so in the step 1 and in the step 3 na ma-produce nga NADPH. So kaning NADPH nga na-produce, this proceeds to cholesterol synthesis, to fatty acid synthesis, to drive those anabolic pathways. Okay, para makabuhat ta og kato nga mga molecules. Okay, so this is the summary of PPP and then the enzymes involved. So the non-oxidative phase of the pentose phosphate pathway, which is the second step, or the second phase, so there is an extensive carbon atom rearrangement. So gi-rearrange lang ang mga carbon atoms. So 10 carbon man na sila tanan kay nag-combine man ang cellulose 5-phosphate and ribose 5-phosphate. If ribose 5-phosphate is not removed for nucleotide synthesis, then ribose 5-phosphate is combined with a cellulose 5-phosphate, okay, to form this pseudoheptylose 7-phosphate and glycerol 3-phosphate by the enzyme transcatolase. But in most instances po, no, ribose 5-phosphate is removed, diri na siya sa nucleotide synthesis. So another metabolic pathway which is dedicated to the production of nucleotides. Okay. So transcatolase enzyme requires thiamine as the coenzyme. So that's why para makaproduce para ma-functional ni sa transcatolase, kinahanglan og thiamine pyrophosphate. And remember guys, that when we want to measure the thiamine status in the body, pwede nato i-measure ang activity sa transcatolase. Okay? So, transcatolase with the help of thiamine, in the form of thiamine pyrophosphate, then pwede ta maka-produce og G3P and fructose 6-phosphate, which will be returned back to glycolysis. Okay. So, epimerase and isomerase. So, epimerase is to convert ribulose to cellulose, which is because ribulose is just an epimer of cellulose. And then, the isomer of ribulose is ribose. So, that's why mauna ang terminologies. And transcatolase. Okay, it requires vitamin B1. Remember guys, katong mga enzymes that also need vitamin B1 as the coenzyme, like PDH or pyruvate dehydrogenase. Okay? And then alpha ketoglutarate dehydrogenase. So those enzymes require B1 as the coenzyme. Okay. So that ends our discussion for anabolism. So we have learned guys nga there is a PPP, diri ta makaproduce og NADPH to drive other anabolic reactions like fatty acid synthesis and cholesterol synthesis. And we also have learned how we produce glycogen if sobra-sobra ang glucose. And aside from that, aside from glycogen synthesis, katong sobra nga glucose, pwede sad nato i-divert into PPP. Okay. So, I should expect questions, no? During sa atong open forum. So, that actually ends our discussion for anabolism. So, actually, nahuman na ta. So, basic lang to siya actually, guys, sa metabolism. So, in med school, pwede siguro deeper pa ana, no? But some other med schools kanipod ang discussion. Okay? Because if you really want to get deeper, and if you really want to um, tackle more metabolic pathways, then um, kung mag-major na ka na og biochemistry, but most likely mao na ang inyong kinahanglan. Okay? Okay, so thank you guys for listening and watching, and goodbye.